In many ways, this whole course is a series of things I want you to do to new code that you write and to code that you get from other people when you are in a place where you can change it. Don't want you to go around messing with working tested code just to make it more readable. But if you're going to use something as a starting point, take it to a nice place. Don't leave it in an old, ugly, crufty place. So just to quickly whip over the other modules in this course, started out by talking about manual memory management, resource management in general especially, opening files and holding locks and database connections. These things shouldn't be done by hand. Especially if you come to C++ from a language like C# or Java, it may take some remembering before you realize you have available to you solid objects. When I see something where there's a pointer to a resource and the constructor, all the constructors knew that resource out on the free store and the destructor deletes it, what the heck? What are you doing? That should just be a solid object. Unless it's so large it can't fit in this object as a solid object, that should just be a solid member variable. And let resource acquisition is initialization be your friend. Your secondary choices are to use the smart pointers, unique pointer and shared pointer. That will handle the management for you so that if exceptions are thrown or other unexpected things happen, resources are still properly cleaned up. You shouldn't be doing this yourself. Everything you knew you must delete is true, but it shouldn't apply to you. You should be immune from that. Lambdas are the key to writing modern C++, for that readability, for that expressivity, so that people can see what things do instead of having to either keep everything in their head or take everything on faith. They are also the key to using algorithms, and using algorithms is the key to using the standard containers. Together, your code is faster, neater, less buggy, and you spent less time writing it. There's really no downside now. Move semantics. You can think of move semantics as a wonderful thing that just happens to you. If you have a vector of strings, you're going to get move semantics in that vector of strings and life is going to be good. If you are writing your own classes, you want to think about, do I want this class to be movable? Do I want this class to be copyable? I like that we have to be more aware of that and think about that because performance matters to us. And when you make a class movable, you can participate in move semantics and you can get tremendous performance enhancements, as you saw in the demos of that section. The pimple idiom, nice way to achieve a compiler firewall so that changes to one class don't require recompiling others, and to isolate your insides more completely than the standard C++ mechanism does. Most of all, please stop writing C with classes. Whether it's the style rules, whether it's switching to vector, whether it's switching to string and stopping to use char stars, whether it's remembering to have some classes in your C++ applications, please write modern C++. It's readable, it's expressive, it's as fast as ever, if not even faster. And, you know, the sanity you save may well be your own if you're the one who comes back later to read it. You can write C++ that everyone can read, and I strongly encourage you to do that.